Namaste Coders, I hope you are fine. So today is 28th March and we are going to solve LeetCode problem of the day. So this is today's LeetCode problem of the day, minimum cost walk in weighted graph. So this is a hard problem and this problem is really very interesting. I have tried this problem and this is very complex, right? So please stay with me throughout the problem. So before starting, this video is a part of LeetCode's problem of the day series, in which we are going to solve all the LeetCode problem of the day daily. And along with this LeetCode problem of the day series, we have also started a LeetCode 75 series, in which we are going to solve the most important 75 questions of the LeetCode, which is most probably going to come into your interviews. So if you want to prepare for an interview, you should watch those videos, right? So along with these videos, I have also created a WhatsApp group for the coders so if you want to be a part of coding community, you can join the WhatsApp group. Link is given in the description box and it's completely free. So the problem is minimum cost walk in weighted graph. So there are an undirected weighted graph. There is an undirected weighted graph with n vertices labeled from 0 to n-1. You are given integer n and integer edges, where edges I is equals to ui, vi and weight I. Okay, ui and vi are connected with weight, right? So this is ui and this is vi. This is undirected graph and it is connected with wi, right? Edge of weight wi. So the question is, we can walk on a graph from, so we will given with the queries, right? So we will given with the query starting and ending, right? So there is we will make a graph which is connected like this. Okay, let's say, and there are something. So we will given a query, so we will start from here, we will go till here, right? And the cost is end of all the paths, right? And the twist is, we can go through any node, including the terminating node, multiple number of times, right? So we can take this path, we can also take this path, right? So, and we have to find the minimum cost of the travel, right? Minimum cost. Cost is nothing but the end operation of all the weights, right? So as you all know, the catch is, more we travel on the different paths, right, the lesser will get the cost, because end operation will make the number less. It can never make the number greater, right? Because end means, if there is a 0 1, right, so it will make it 0. If there is two ones, right, then only it will become a 1. Otherwise, in this case or in this case, right, this will become 0. So more we get the numbers, different byte, different unset bytes, more lesser will be our cost. So this is the first catch. And the second catch is, we can travel if there is a graph which is connected like this. Okay, anything, I mean, this is not exactly what I want, but okay, there are these nodes, so we want to go from here to here, so we can go like this also, right? So this is given in the question, you can read this. Walk more than once, right? Same edges or vertex more than once. So this is given. So there, another catch is, we have to find the end of a whole connected graph, because if you want to go to here na, we can go through all the edges, right, like this, and we can so we can take the advantage of all the weights. So from going from one point to another point in a connected graph, the cost will be AND operation of all the weights. So the two catches we get is, first we have to find the lowest cost, which will come from the maximum number of edges will travel, and in a connected graph we can travel all the edges. So for traveling from one edge to another edge in a connected graph, the cost will be AND of all the edges, and in a disconnected graph the answer will be -1, because there is no path there. So now our task is to, let's say our graph is like this is one component, okay, and this is another component, let's say something like this. So our task is to find all the end of this graph and all the ends of this graph, right, in all such graphs, and then we will answer the queries. So this is a straightforward problem from union find. If you are not aware of union find, I must suggest you that you should go through the previous videos where the union find is, I understand, like explain the union find in a very depth. So I will share the link with you in the description box. You can go through those videos as well. So union find is must for this question, right? Without union find we cannot solve this problem. Okay, so how to solve this problem? So union find, in using union find, what we can do is we can find the through union find, right, we can find the AND operation of between all the edges in all the connected graphs. So how to do that? So यार मैं अभी बाद में आऊँगा, थोड़ी देर में आता हूँ, 10 मिनट में आता हूँ, तुम लोग पहुँचो. So this is the code. Let me explain it to you. So this is the standard.
आपका हुआ नहीं हुआ?
वही कर रहा हूँ, थोड़ी देर में आता हूँ.
कितना हुआ? कर क्या रहा है?
वही कर रहा हूँ, मतलब हो तो गया वैसे, बस.
कर क्या रहा है? कर अप्रोच क्या है?
यूनियन फाइंड.
तो उससे नहीं हो रहा?
उससे हो रहा है, हो गया, बस बोल रहा हूँ एक बार.
अच्छा प्रिपेयर कर रहा है खुद? अच्छा सवाल हो गया,
हाँ
सबमिट. अच्छा ठीक है, कितनी देर में आ रहा है? नीचे आ रहा है?
5 मिनट में नीचे आ रहा. Okay, so this is the standard method for solving for the union find. So this is the implementation of find, in which if we so this is the implementation of find and this is the implementation of union, but we have just add this line, right? This is parent weight of find A is weight and parent weight of find A and parent weight of find B. Parent weight is nothing but this. And what is this? This is and 0 means 1 1 1 1 1 1 1. Why 1? Because whenever we use all ones, right, and do a AND operation with an n number will retain same, because 0 and 1 will always become 1, and 1 and 1 will become 1. So that's why we are using all ones, right, or here. So again here the parent weight of find A is weight, the given weight, and parent weight of find A and parent weight of find A. So let's say we are joining two disjoint graphs, right? It has A and it has A value, which is the end of all the edges in this graph. It has B value, which is end of all the edges in this graph, and this is WT, this is weight of the edge. So the end of whole connected graph will become A and B and WT. That is what we are doing, A and B and WT. and then we will make the parent of find b the parent of b the parent of a. So let's say this is graph a, this is graph b, this has parent this, this has parent this, so this will now point to this, so that the whole graph has common parent this, and the weight of this graph, this point, we are calculating using this. So that's how we are using union find to solve this method, solve this problem, right? Okay, so in this main method, what we are doing, we are first initializing our parent of I is nothing but I, so initially all has the self parents, and then we are using the weight as all ones. Then we are, for every edge, we are making the graph using union, and then for every query, we just have to, what we have to do, we have to find if they are connected. If that means the parent of a is equals to parent of b, parent of a is not equals to parent of b, that means they are not connected, both have different parents, right? So we will return -1. Otherwise we will find the parent of a, we will find the weight of parent weight of a, right? So this is the answer. So this is the very simple implementation of this hard problem, right? But this problem contains first bit manipulation, right? Bit manipulation, second union find, so this is a bit tricky question, I must say, but yeah, very interesting one. So I hope you understand this well. So thank you for your time. Please stay connected with me using the WhatsApp group, using this YouTube channel. So thank you for your time. Have a nice day.